Chokde nipa di nima nga zu mutu yi, chokde nipa nga zu indicators kola, and di nama mutu shu yi, indicators. Indicators la na kharire, indicators ki type khazu yorwe, and indicators ni zonga zu ki, and bechu karistango yume, na wadi zu thola nyetari di nama shu yi. Indicators are substances that change color when they come in contact with acids or base. Acids down base nyamdola and korangi indicators tiki nyamdola acid the base nyamdo contact chungota china indicators down acid the base is for contact chungota china any konzo kachis na color change is. Or the color change ki substance chula we call it as a indicator. Indicators are those substances which change color when they come in contact with acids or base. And those say substance which change color to indicate that the substance is either acid or base. Konzo color indicators tigi konzo color change they indicate. Konzo indicate indicate the range tigo. Shema konzo ke chen yo barwa. Medu ne konzo kachu color change. Oh, the color more so chezaho acid in the base in the color more so acid in the base in the rare color change in the lens cheza o the color change in the landing substance in the chila we call it as indicators. The indicator the indicator thing on the natural indicator tang artificial indicator or synthetic indicator synthetic indicator tang natural indicator indicator the indicator so indicator natural indicator tang synthetic indicator. Now, what is natural indicator? Natural indicators are those indicators which are prepared from natural resources, such as red cabbage, such as turmeric, such as lichens, or the Indian extract indicators natural indicators. And then if indicators are made or prepared in a laboratory, chemistry laboratory, those indicators are considered as a synthetic or man-made or artificial indicator. Indicator the natural indicator litmus tigacha khane rarsna lichens around it. Turmeric, okay, these are natural indicators. Natural indicators are litmus, turmeric, red cabbage, China rose, say onion. Vanilla. Okay, these are say natural indicators. Litmus, turmeric, red cabbage, China rose, onion, vanilla. These are natural indicators. And then there are synthetic indicators. Synthetic indicators like methyl orange, phenolphthalein, so these are synthetic indicators. Synthetic indicators are methyl orange, phenolphthalein, universal indicator what the day. Okay, natural indicators like litmus and turmeric, red cabbage, China rose, onion, vanilla, all these are indicators. And natural indicators are indicators which are not man-made. Synthetic indicators are those indicators which are man-made or prepared in a laboratory. Okay, so in this manner, indicators are of two types. Now, how we make use of this indicator? Which types of indicators change into which types of color with acids or base? Indicators khari imba and indicators dige type khari imba or dige mod yeah. Anyway, indicator why we have to depend on indicators. As usually we say that acids they test sour and base they test say bitter. Base tenzo khati yodes, acid tenzo and cumulative yodes. Manzuki hapo the indicators kharchin bejutang yodes. Indicators tige never bejutang yodes. Kharchins na acids and base are highly corrosive. Acid the base like the best chemical strong chair and harmful. Cheza manzula kharchusna acid the base tenzola lapo chaya and toa diet in the namiche. Cheza ta toa diet mena lapo chaya mev the china anzu khadechine in indicators. Khadechine anzu acid the base with the help of indicators. With the help of indicators, we can identify a substance contains acids or substance contains base. All those. The indicator identify with this table. That's understanding. Okay, let's write down indicators here and then its original color and then with acid, change with acid and change with base. All condition on it. Red litmus. Original color दिखा litmus दिखे under the red check. Generally, litmus, the color of litmus is purple, but we prepare it as a red litmus and blue litmus. So the color say red or say blue or this red. Red litmus in acid no change in color. Red litmus in base changes to blue. Blue litmus. Blue litmus. Blue. Here. changes to red, no change. Here no change means no change in color. Okay. Turmeric, as you know, in our kitchen, the color of turmeric powder is yellow. So the original color is yellow. But this yellow, when it come in contact with acid, no change in color. No change in color. But when this yellow turmeric powder comes in contact with base it changes to reddish. Reddish brown. Okay, then red cabbage, original color is purple, but with acid red cabbage will gets converted into reddish, and with base it gets converted into greenish yellow. So red cabbage, its original color is purple, but with acid it gets converted into reddish, and then here with base it gets converted into greenish yellow. And then onion. So onion, you don't have to here. Smell. We are checking this onion on the basis of its smell. It indicates us by giving smell or not giving smell. So this onion and vanilla are considered as a olfactory indicator. Smell here with acid. With base, smell vanishes, smell disappears. No smell. Okay, so here, this is the table here. Yeah, out of this table we can understand that which kinds of indicators can change color. color condition change here. And here these two onion and vanilla are say indicators which are considered as an olfactory indicator. Olfactory indicator. Olfactory indicator. Onion and vanilla. Okay, these are called as olfactory indicator because they indicate the presence of acids or base by giving their smell or by not giving their smell. So that's why out of smell we are able to understand whether the substance contains acids or whether the substance contains base. So these types of indicators are called as olfactory indicators, and these olfactory indicators also belongs to natural indicator. Natural indicator part belongs to this. Yeah, the red litmus in a Korange, actually this litmus, their colors are purple. Actual color of the litmus is purple. Actual color of the litmus is purple. But then we convert this purple color to red and blue by say in when we prepare those litmus in our lab, we change their color into red and blue. So red litmus, or you can say in the form of solution also you can get this red litmus solution or red litmus paper. Similarly, red litmus, blue litmus paper and blue litmus solution. So this litmus, say red litmus, when it come in contact with acid, the color remains red. Color remains red. So no change in color. Its original color is red. So no change in color. But this red litmus, when it comes in contact with base, it gets converted into blue. Red changes to blue. When red color of the litmus changes to blue, the substance is acid. Substance contains acid or the acid areas. Similarly, in terms of blue, blue litmus, its color is blue. With acid, it changes to red, but with base, there is no change in color. Color changing. Turmeric powder, you have learned these things in the in one of the activity in class 7 also. Okay, yellow. The actual color of the turmeric powder is yellow. So this yellow color, when it comes in contact with acid, it remains as yellow. So there is no change in color, but with base, it changes to reddish brown. It changes to reddish brown. Red cabbage, actual color of the red cabbage prepared is purple. But when it comes in contact with acid, it changes to reddish, kind of a red. Okay. Then when it comes in contact with base, it changes to greenish yellow. Greenish yellow. Regarding this onion and vanilla, they are olfactory indicators. They smells onion or smell of the vanilla, they gives it when they come in contact with acid. But when they come in contact with base, the smell vanishes completely. It does not smell. So from there we can understand that these kinds of substance contains base. Okay. Then here methyl orange and phenolphthalein, these are synthetic indicators. Synthetic indicators. And here these synthetic indicators, methyl orange, its actual color is orange, but with acid it changes to red, and with base it changes to yellow. So it indicates a lot. And then phenolphthalein, it is usually colorless. We can say colorless, say like water. Water is colorless. So like that. When phenolphthalein come in contact with acid, it remains as it is, no change in color, no change. But when this phenolphthalein come in contact with base, it gets converted into pink. So this is how the indicators, they indicate us by giving or by changing their color, or by giving smell, or by not giving smell. So this is all about indicators. So these are how we use indicators. So with this, I'm going to keep the second period over here.